Image, a close-up shot of a human eye dilating as the reflection of a bright, distant star field fades into view. If you were to shrink the entire history of the universe into a single calendar year, modern human civilization would appear only in the final seconds of the very last day. Everything we have ever known, every war fought, every discovery made, and every person who has ever lived, occurred in a fraction of a heartbeat. But what if I told you that our current understanding of this timeline is fundamentally incomplete? Image, a wide-angle cinematic shot of the Milky Way galaxy arching over a desolate, rocky desert landscape at night. What if the most important parts of the universe, the vast majority of its substance, are completely invisible to us? We live on a fragile blue marble suspended in a void so expansive that light itself takes billions of years to cross it. Yet, we are the only species we know of that has looked up and asked, how did this happen, and where does it end? Image, an animated digital graphic showing the Big Bang expanding into a colorful, glowing web of galaxies. Today, we are going to peel back the layers of the cosmos. We aren't just looking at stars, we are looking at time itself. We will traverse the history of the Big Bang, examine the invisible forces holding galaxies together, and finally, confront the ultimate fate of everything that exists. Image, the high-resolution stock image of a swirling, golden-hued galaxy with a bright, luminous core. The universe began approximately 13.8 billion years ago. Before this moment, there was no where and there was no when. Space and time were locked in a singularity of infinite density. Then, in a trillionth of a second, the fabric of reality began to stretch. Image, abstract CGI visualization of rapid inflation, showing particles scattering across a neon-tinted void. Inflation was violent and fast. It laid the foundation for the structural geometry of the cosmos. As the universe cooled, matter began to clump together, drawn by the invisible hand of gravity. Image, close-up of glowing gas clouds condensing to form the first protostars in a dark, dusty nebula. These protostars ignited, creating the first light in a previously dark expanse. These stars clustered into galaxies, and these galaxies organized into the grand, web-like structures we see today. Image, a long-exposure shot of a deep space telescope capturing thousands of multicolored galaxies in a single frame. But here is where the story takes a turn. When astronomers look at how galaxies rotate, the math doesn't add up. The outer stars move just as fast as the inner ones. By all accounts, they should be flying off into the void. Image, a conceptual art piece showing a transparent, ghostly halo surrounding a vibrant spiral galaxy. They aren't, because of something we call dark matter. It doesn't emit light. It doesn't reflect it. It is entirely invisible. We only know it is there because of the way it tugs on the visible matter we can see. Image, a complex, computer-generated simulation showing the cosmic web with glowing filaments of dark matter connecting distant clusters. It makes up about 27% of the universe. Regular matter, the stuff that makes up you, me, and the stars, is a mere 5%. The rest is dark energy, a mysterious force pushing the universe apart faster every second. Image, the minimalist graphic showing the acceleration of space expansion, with galaxies drifting further apart over time. For most of the 20th century, we thought gravity would eventually slow the expansion of the universe. We thought it might even collapse back into a big crunch. But we were wrong. Image, a stark, isolated image of a dying red dwarf star against the infinite blackness of space. The universe is not slowing down. It is accelerating. Every galaxy that isn't bound to ours by gravity is moving away from us. Eventually, they will cross a cosmic horizon beyond which light can never reach us. Image, a dramatic wide-angle shot of a lone astronaut looking out from the ISS window at the curving horizon of the Earth. This leads us to the midpoint of our journey, a realization that changes everything. We are essentially living in an island universe. As time marches forward, the night sky will eventually go dark. Image, an artist's rendering of a futuristic, dark sky with no visible galaxies, representing the distant, lonely future. Future civilizations, if they arise, will have no evidence of the Big Bang. They will see only their own galaxy, surrounded by an eternal, empty void. They will conclude they are the center of a static, lonely universe. Image, a conceptual depiction of a black hole bending the light of stars in the background, showing the gravity well. But we are lucky. We are here at the perfect time to witness the tapestry of the cosmos before it unravels. We are here to study the heavy elements forged in the hearts of dying stars. Image, a close-up, high-detail rendering of a supernova explosion, showing bright orange, purple, and blue gases expanding outward. When a massive star dies, it explodes, scattering gold, silver, and carbon across the galaxy. These are the ingredients of life. Your body is quite literally made of stellar debris. Image, a microscopic view of DNA strands morphing into stylized star charts and nebula shapes. You are not just a spectator of the universe. You are the universe, contemplating itself through the eyes of biology. This is the central irony of our existence. Image, a wide shot of the Hubble Deep Field Image, showcasing the incredible number of distant, faint galaxies. The distances involved are so large that our brains struggle to process them. If our solar system were the size of a coin, the nearest star would be miles away. Image, a conceptual illustration of two galaxies colliding, showing stars being flung into intergalactic space. Galaxies collide, too. Our own Milky Way is on a collision course with the Andromeda Galaxy. In 4 billion years, they will merge. Image, a cinematic shot of a glowing, ethereal nebula structure floating in space. It won't be a catastrophic collision, but a slow, graceful dance. Billions of stars will pass each other without ever touching, creating a new, massive elliptical galaxy. Image, an artistic representation of a massive black hole at the center of a galaxy, with an accretion disk glowing brightly. At the heart of almost every galaxy lies a supermassive black hole. These are not monsters that wander the universe consuming stars, but anchors that keep galactic systems in balance. Image, a close-up of a telescope mirror being polished in a cleanroom environment. We build telescopes like the James Webb to see deeper into the past. Every photon hitting those mirrors is a message from millions, or billions, of years ago. Image, a high-contrast image of a faint, redshifted galaxy, the oldest one ever observed by modern technology. We are effectively looking through a time machine. The farther out we look, the further back in time we see. Image, a conceptual animation of light waves stretching as they travel through expanding space. Yet, there is a fundamental limit to our vision. We cannot see beyond the cosmic microwave background, the afterglow of the Big Bang. Image, a vibrant, colorful map of the cosmic microwave background radiation, showing tiny fluctuations. Everything before that moment is currently hidden from us by a wall of opaque plasma that existed when the universe was only 380,000 years old. Image, of a wide, serene view of a star-filled sky over a calm ocean. So, what lies beyond that wall? Are there other universes? A multiverse? We don't know yet, but the math suggests it is possible. Image, a thought-provoking animation of multiple, overlapping bubbles, each representing a separate universe. We are in the midst of a scientific revolution. We are learning how to detect gravitational waves, ripples in space-time caused by the collision of black holes. Image, a graphic representation of ripples spreading through a grid, simulating gravity waves. This allows us to hear the universe, not just see it. It is like being deaf for millennia and finally being given the gift of sound. Image, a shot of a scientist at a computer screen monitoring a complex waveform in a research laboratory. Every day, the boundaries of our knowledge expand. We are identifying exoplanets, worlds orbiting other stars, in numbers that would have seemed impossible just 30 years ago. Image, a colorful, artistic interpretation of a planet with two suns setting on a distant horizon. Some of these worlds might be rocky like ours. Some might have water. Could there be life? The odds are high, but the distance is the ultimate barrier. Image, a close-up of a radio telescope dish pointing toward the deep, silent expanse of space. The silence of the universe is loud. We call it the Fermi paradox. If life is common, why haven't we heard from anyone else? Image, a solitary astronaut standing on the surface of the moon, looking back at the tiny Earth. Perhaps we are the first. Perhaps we are the vanguard of consciousness, tasked with carrying the light of intelligence into the future. Image, a wide, awe-inspiring shot of a massive, glowing spiral galaxy seen from a distance. The scale of the universe is not meant to make us feel small, it is meant to make us feel significant. We are the architects of our own understanding. Image, an animation of the Earth slowly zooming out to show the solar system, then the Milky Way, then the local group. We exist in a rare pocket of complexity, capable of mapping the stars, calculating the mass of galaxies, and pondering our own origins. Image, a close-up shot of an older person pointing at the stars while teaching a young child. This search for answers is the most fundamental human endeavor. It is the drive that took us out of the caves and onto the moon. Image, a montage of various space exploration rockets launching into the night sky. As we look toward the future, our next steps will involve deeper exploration of our own backyard and perhaps, one day, venturing to another star. Image, a conceptual shot of a generation ship traveling through a star-filled void toward a distant sun. It will not be easy. It will require a global effort and a commitment to science that lasts generations. Image, a beautiful, artistic shot of a sunrise seen from the surface of a distant, alien planet. But the universe is waiting. It is a vast, beautiful, and sometimes terrifying expanse of potential. Image, a slow fade out from a bright star to the pitch-black void of space. The mystery is not going away. In fact, the more we learn, the more we realize how little we truly understand. Image, an abstract representation of light rays converging into a single point of illumination. And that is the beauty of it. The questions never end. The curiosity that defined our past will continue to define our future. Image, the final shot of a person standing on a cliff edge, looking up at a sky overflowing with millions of stars. We are part of a grand narrative that spans billions of years. We are the storytellers of the cosmos. Image, a clean, black screen with a single, small, glowing star in the center. The final horizon is not a place, it is a direction. It is the direction of discovery, of wonder, and of humanity's enduring need to know what lies beyond the dark. Image, the slow zoom out from the star until it vanishes into the vast, infinite blackness. Keep looking up. Keep asking why. Because as long as we keep searching, we will never truly be alone. Image, a fade to a black screen with the channel logo in the center.